Hello, everyone, and welcome to SNIA's Cloud Storage Technology Initiative webcast. The topic today is storage scalability in hybrid cloud and multi-cloud environments. My name is Pekon Gupta, and I'm a solutions architect at Modular. I'll be your moderator today. We have a great set of panelists today who are also the SNIA expert in the technology of the topic. I'm being joined by Robert Cohn from Intel and Piyush Chaudhary from IBM. Robert is a senior principal engineer at Intel. He's responsible for infrastructure workloads and architecture in cloud and enterprise. Rob is based out of Oregon, and he joined Intel in 1997. He has worked as a design engineer, micro-architect, an architect on various SoCs, NICs, and chipsets. Welcome, Rob.
Hello. Thank you.
And we have our next presenter, who is Piyush. Piyush joined IBM in 1997. He has spent significant time working in the HPC organization on Spectrum Scale, which is IBM's high-performance cluster file system. Most recently, he has taken on a role of lead architect for transforming Spectrum Scale for cloud-native and hybrid multi-cloud deployments. So welcome, Piyush, to the presentation.
Thanks, Pekon. Glad to be here.
Before we proceed further, a little bit of disclaimer from the legal side. It's just a quick note. The presentation you see over here is copyright by SNIA unless otherwise noted. SNIA members may use this presentation as long as it's used in its entirety and SNIA is credited. There are no warranties expressed or implied, and use at your own risk. And a little bit background about what SNIA is. So before we dive in, SNIA is a non-profit global organization dedicated to developing standards, education programs for advancement in storage and information technology. We have 185 leading organizations participating in SNIA, 2,000 active members, and a reach over 50,000 IT users, professionals worldwide. Within SNIA, the chapter which is presenting the topic over here is Cloud Storage Technology Initiative. As you can see, the CSTI covers a broad range of storage-related topics through educational webcasts like this one, blogs, and the presentations at the industry events. So without any further ado, I move towards the agenda. So today's agenda is the first half would be covered on the topic of hybrid cloud, multi-cloud environments by Rob. And the second half would be on hybrid cloud, multi-cloud storage requirements by Piyush. Before I hand it over to the presenters, a quick note. At any point of time during the presentation, you may submit your questions through the chat window, which you see at the bottom of your page. We will take your questions towards the end of the discussion. And if we are unable to answer all of them, we'll let you know through our blog. The slide deck for this presentation is also posted on the attachment tab, as you see on the bottom of your Bright viewing console. So you can download it from there. So I hand it over to our first presenter, Rob, from here.
Thank you, Pekon.
Rob.
All right. So digital transformation is necessary for remaining competitive in today's quick evolving market. Laying a modern foundation is critical to achieve transformation. 60% of the global GDP will be digitized by 2022, with growth in every industry driven by digitally enhanced offerings. This transformation is driving a huge increase in the amount of data being stored and moved in the cloud. It's no surprise that we're living in a world of extreme change. Rapid, disruptive change is the new normal. Without evolving, it will be difficult for some enterprise companies to grow. Digital transformation is a key element of this disruption. It's so fundamental that 72% of global CEOs are using tech to disrupt their sectors rather than waiting to be disrupted. Rather than fall behind, enterprise companies are adopting new business models by expanding into the cloud. The bottom line is that while this level of change feels significant, this is the least amount of change any of us will ever see. There are many ways to leverage the cloud. Many enterprise companies today use some form of method on the left, which is OnDemand Cloud for storage, backup, and caching. Here, you just use one of the services as is for storing data or passing data to a client or customer, like Dropbox. In the center, we have lift and shift. A lot of enterprise companies also choose to adopt lift and shift methods. CC will touch on concepts for lift and shift during the second half of the presentation. I will briefly discuss integration of microservices on the right, which allows businesses and DevOps to place miniature workloads throughout one or more cloud data centers to take full advantage of the flexibility and scale of the cloud. Before I jump into microservices and data placement, I'm going to go over a few definitions of the cloud. So private cloud is the transitioning of a traditional enterprise data center to a cloud-like architecture. It can include incorporating native cloud apps like Spark or Hadoop. And in some instances, it has CSP framework or hardware that is located on-prem. Hybrid cloud is the combination of on-prem, often a private cloud infrastructure with the public cloud, and being able to orchestrate between the two platforms. And multi-cloud is the use of multiple cloud computing environments and storage services in a single heterogeneous architecture. Multi-cloud also refers to the distribution of cloud assets, software, and applications across several cloud hosting environments. Multi-cloud architecture typically combines two or more public clouds with one or more private cloud to eliminate reliance on any single cloud provider. And cloud architecture is the most efficient and agile computing solution, regardless of where it's deployed. So now that I've kind of given the definition of cloud, what I want to talk about is where data is placed. Data can be placed in a cloud data center over on the right. It could be at the network edge. It could be on-prem, or even in some instances on the actual device itself. One of the things to think about when placing data is how much data you need to move. Moving data across the data center can be very expensive. Also, you need to think about latencies. If you're moving data all the way from the cloud to a device, the latencies can oftentimes be can affect your application that you're trying to run. So now that I kind of talked about data placement, let's think about how do you even choose, which cloud service provider to go with. Each cloud service provider specializes in different things, and oftentimes are better in one thing versus others. So it's best to sometimes look at more than one cloud service provider. Though there can be difficulties with doing this. Looking at one cloud service provider versus another, sometimes they have different ways to interact with data. They have different APIs that you have to use or different services. And so the person who is running the specific app on the cloud needs to understand how those services work. So evolution into multi-cloud can be tricky. The buyer must beware and be a smart shopper and take advantage of getting exactly what they need to keep costs down by leveraging more than one. It's good to come up with a strategy first before just jumping in. So I'm going to kind of go through an example of microservices, starting off with Netflix. So everybody kind of probably remembers back when Netflix first had DVDs, and they used to ship DVDs to people. And then they got the idea that they wanted to be able to offer these same movies online. When they had their original main data center, and they figured they had to move content from that data center to a bunch of different regions. That latency came into play. And so what Netflix ended up doing is they've broken up their service across their apps, essentially what they call the CDN or OCA, which is a content cache device. And then AWS is where they run all their back-end stuff. So when you log into Netflix, you're usually logging into AWS, and from there, all the picking and playing of the movies happens there, and then it goes into the context cache and sends that over to the CDN and sends that over to the apps. So doing this, they had to do this over time. It took them multiple years to essentially rewrite their original software that they had, which was monolithic architecture, into microservices. So what I'm showing up here is kind of progression of the different microservices that they wrote and their evolution. The nice thing about this is that once they built this framework, it allowed them to be able to independently update these specific microservices independently, and it didn't affect the larger application. This gives them a lot of flexibility. The important thing to know is that now they have the flexibility, they have the scale, and they have internal architecture and framework to be able to deploy rapidly, and also meeting their customer requirements. They can add in testing and analytics to improve the services. And they don't have to wait to have that migrated into their large monolithic software. So this is kind of jumping down into what their architecture looks like on AWS. The framework that they built here started with streaming, but they keep adding more and more microservices to help them deliver the best product to their customer. They have APIs that allow their devices to be able to connect into those microservices, and for the microservices to be able to talk to one another. The microservices can do a lot of things, like analytics on data. They can also look at what you've been searching on and what you've been navigating, which help when you bring up the screen to put things on there that you like. It also talks to the CDN devices that are at the edge. And those CDN devices have different routes to get to the user. And it works with the CDN devices to help them determine the routes. And this is just to name a few of the microservices on there. Let's just kind of jump to a high-level example here. Most of the traffic that's generated from a user is called NorthSouth Traffic. So when a user goes and it wants to use a specific service, that traffic goes to a data center, and that data center could have a bunch of microservices running. Those microservices can be spread across the entire data center to help with efficiency and to give better utilization to the CPU. Those microservices typically talk to other microservices of what we call east-west traffic. And that's how they also get data and do processing. Data is typically disaggregated from the microservice. So when the microservice wants to get to that data, it'll request the data, possibly do analytics on it, could do machine learning or inference, could also update the data. You can write a microservice that can be used in many different places across your businesses. So you may write one microservice that could be used for one part of your business that can also plug into another part of the business that may have more microservices that are different. This allows for you to be able to run something once and make sure that it works versus doing something multiple times. It could do the same thing. So microservices give you the flexibility and utilization to be able to adapt workflow across streaming pipelines. So in here, we have the data that's on the bottom, and you could access databases, big data, it could be data lakes, persistent storage. The microservice then may do something like machine learning or inference, and then that goes and gives you a result, which then may place an ad or something back up to the person who was accessing that website. Having common APIs allows for microservices to be able to be used easier. But in today's world, many different CSPs have different APIs, which makes it difficult. As you can see, we've now split the microservices across the public and multi-cloud, edge, and private cloud. They can face workloads in any one of these locations based off of what I mentioned before, SLAs in terms of how the latency that they need to be able to deliver the data, as well as cost. So they may place certain stuff in the cloud because it has a better cost structure and they don't need to move that data. Oftentimes you may want to use AI services from the cloud. So sometimes having a lot of your data sitting in the cloud where you can easily run a data set on that data, or run that data through a data set is valuable. But they also may want stuff that's in their private cloud that they want to have. They want to control the level of security that they have. Being able to split their workloads across public and multi-cloud, edge, and private cloud gives them a lot more efficiency. And this here is a very deeply integrated use of microservices. And not everybody will just start doing microservices. And most people, when they start in the cloud, they start with the simpler model of just using, either storage in the cloud or caching. This is kind of like the more complicated far end that you get after multiple years of the cloud. And some people may never get there because they don't need this type of complexity. So next, PC is going to show integration into the cloud from another angle. And if any of you have any questions, feel free to put them in the chat window. And if we run out of time, we will make sure that we answer these questions. All right, thanks. PC?
Thanks, Rob. All right, so let's take a look at what our customers are actually doing already today. And one of the things that is very evident is that the public cloud has been successful in showing some of the things that our customers have been struggling with on their premise data centers. So cloud deployments, they provide lots of infrastructure agility. And customers are using this agility to their advantage for rapid deployment, scaling, and decommissioning of storage. This works really well in the cloud, and this is all of these advantages and some of the benefits I'm going to talk about, right? This is the same kind of experience now these enterprise customers are starting to expect for their IT consumption within their data center. So like Rob had mentioned, that on-prem cloud-like consumption model. The public clouds actually scale really well too. They provide, in effect, nearly unlimited scaling, and this is all on demand. And we have customers who are already exceeding exabytes of storage capacity. And in terms of containers, they're exceeding million container volumes. And the public cloud is really good at this. But some of the challenges that we're seeing is that as the capacity scales, so does the need for performance. And for at least the file access mechanism, the file system perspective, this is not something that has scaled very well. So this is a challenge that will have to be solved because applications are now already pushing past the boundaries of hundreds of gigabytes per second and millions of IOPS in performance. IOPS is a sort of a not the right way to measure latency in a file system concept, right? That's more like a block storage kind of a thing. But think of it as random reads, maybe 4K random reads. But there are actual applications in high performance computing, technical computing, analytics, AI, cognitive, that demand this kind of performance and at scale. And this is where I think that there's going to be work needed from both the IT departments in the data center as well as public cloud providers. One of the good things that we have seen is that API-driven deployments are improving the speed and developer productivity. This is very, very critical, and this is what's led to the transformational nature of new application development, because this really reduces the time to solution and allows for rapid innovation. So even though enterprises will start with a lift and shift model of their existing applications, they will quickly realize the benefit of, this could be within their own data center as they move to a cloud-like model. They'll start with that lift and shift and the infrastructure agility benefits that I highlighted here, right? They will start taking advantage of that, but eventually they'll start getting into more hybrid kind of application development where they start taking advantage of these APIs, new microservices that Rob had alluded to, and getting these blended applications going forward. Okay, so I talked about some of the good things, but let's talk about some of the barriers to this evolution. And as technologists, it's our job to reduce this friction, identify these barriers and bring them down. And the fact of the matter is that enterprise applications don't exist in a vacuum. They need an ecosystem for support. And these are the few of the things that I'm highlighting, right? Native encryption, secure arrays, backup and archival, authentication, authorization, auditing in enterprise applications or industries that are heavily regulated. It could be in the financial services area, healthcare area, or even in the new burgeoning field of AI. There's going to be records that need to be kept, provenance, governance, the need to retain this data for some period of time. So all of this infrastructure and ecosystem needs to come with it before enterprises feel comfortable that they can move. One of the new ones concerns that, and it's really relevant in the cloud, is data privacy. We'll talk about that a little bit, but this is one of the first things now enterprises are asking for, is that how does a particular infrastructure help them meet their data privacy and compliance goals. But once you get to this kind of a multi-cloud scenario, hybrid cloud, there's new challenges that pop up that didn't used to exist that need to be solved now. They relate around the movement of data, the sharing of data. As the data grows and needs to be shared with partners, how do you build a trust model that allows you to safely and securely share that data? And how do you deal with the hidden implicit costs sometimes of this movement of data? It's much cheaper to move data into the cloud, but in the public cloud, if you want to move that back out, the egress cost can be substantial. So how do you create workflows that allow you to do your work, yet you don't incur these extra costs underneath? So we'll go through and talk about some of these things. So let's talk about these kinds of requirements that need to be met for applications and enterprises to be able to adopt hybrid multi-cloud infrastructure. So one is around security. So 3 A's of security are very, very important: authentication, authorization and audit logging and audit control. How do you guarantee that a user or a particular service is what it says it is? It's easier to decide this when you're using a known set of infrastructure within your data center. But when you extend that to the cloud, and especially multiple different clouds, how do you make the connection across all of them? Because clouds provide their own, for example, sometimes native authentication mechanisms. How do you federate these together and create a trust model that extends beyond your data center? How do you do authorization? Make sure that not only do you know you can reliably enforce who can access this data, but afterwards prove that you were able to control this and you have a record of who all was able to access this data. And this gets very, like I mentioned in the previous slide, very, very important in heavily regulated industries where there's financial penalties associated with breaches of data or loss of control there. Data protection, we know about encryption at rest, encryption in motion. That is very, very important. But how does that work also for the erasure of the data? Because if you, the cloud infrastructure is easily reusable, right? You scale up, you quickly do your work, you let go of those resources, somebody else comes behind and get access to the same resources. How do you ensure that they're not going to be, there's no data leakage? And there were several high-profile incidents in the public cloud that were pretty embarrassing, and where some enterprises were exposed, or their data was exposed like that. And again, I want to mention that in the hybrid multi-cloud, right, a single point solution that is offered by a particular provider is not sufficient. You need a solution that works across all of them. So one of the things that's going to become important are open standards and collaborations on open standards, so that it doesn't become a big integration mess for IT departments, for enterprises to try to make these things work across all of the different public clouds and on-prem. There's still a lot of room left for innovation, like storage providers or providers of security software, right, can still differentiate, but you need a common sort of federated approach that allows you to accomplish these goals across this landscape. So continuing in the same vein, as I had mentioned, data privacy is becoming extremely important. If you see a couple of years ago, the European General Data Protection Regulation, known by its acronym GDPR, came into effect. And this caused a sea change of behavior on the parts of the enterprises, how they collect data, what data they collect, how do they retain it, for how long, the ability to be able to identify upon demand what data has been collected on that might be associated to a particular individual or institution, and being able to remove that or anonymize it and so that you can use the aggregate data in other ways, right? This has become important. And now it's coming to the United States, where California passed a law that is similar in scope, called the California Consumer Privacy Act. So what has become extremely clear is that data privacy cannot be an afterthought. There are more and more things that you can do by taking data or privacy information or personal information and stitching together a very detailed profile of your customers or users. And so it's become incumbent upon these enterprises that they be able to prove that they're managing it in a secure fashion. And they're looking for this capability to be from the storage providers or the solutions across this hybrid multi-cloud landscape. Backup and archive, right? These kinds of requirements don't go away. These are very, very pertinent in this arena, and in fact become more complicated. If my data, if I'm going to be able to deploy applications and The public cloud that I use is based upon the spot pricing available to me. I need to be very careful about deploying workloads there and not having the data protection that I need there for backup and archival purposes. And a lot of times in the public cloud or in this big data or data lake kind of concepts, people use replication as a way to increase data durability. What's important to understand, though, is that replication is not backup. If a user deletes something, that deletion of data is replicated across all of the copies of the data. So you still need a backup to be able to go back in time and get to that critical information that might have been deleted accidentally or on purpose, but now there's a need for that data again. Archival data to meet regulatory environments, like in pharma companies typically have to save data for 7 years, even after that's been approved, right? And those dates actually, or the time requirements, keep increasing. Right now, a lot of people are developing AI systems, and the raw data that they're using for training, it's all being saved up because there's a dearth of regulations, or there's not enough clarity in the regulations. So in order to be able to protect themselves, a lot of these enterprises are saving all of the raw data as well as the models that they're using to develop these inference engines. And as you can imagine, in industries like automotive, where autonomous driving is a big topic these days, this data can balloon dramatically. A few years ago, it used to be that a car in an autonomous fleet, in a test fleet like that, would generate around about 4 terabytes of data a day. Nowadays, we are in the realm of 75 terabytes of data a day. And you can imagine this, as these fleets grow to millions of vehicles, the scope of the data that we're talking about becomes immense. And so there needs to be an infrastructure that can cope with that amount of data and provide the regulatory and compliance peace of mind to these enterprises that their data is being properly handled and cared for and protected. So this is going to be something that cloud service providers, IT organizations are going to have to deal with, and they need a good systems in place to be able to answer these issues. One thing to keep in mind is that there are all those certain simple applications, right, like simulation or something that start with a simple seed data and just use a bunch of infrastructure and then release that infrastructure when they're done. The truth of the matter is most applications in the enterprise are actually workflows. And there is a need to automate that workflow, because the complexity, while the cloud-like infrastructure is nice, and especially hybrid multi-cloud lets you lower your cost and not get tied into a particular provider, that comes at the expense of complexity. And so to manage that complexity, automation becomes very important. And so what's needed is data workflow automation as well. So one of the ways you can try to build upon that is by extending your enterprise data plane to span this hybrid multi-cloud infrastructure. Once you have certainty that this hybrid data plane gives you the security, gives you the resiliency, the data availability and protection that you're looking for, then you can start building automation on top of it much easier. So make sure that the data is available with the appropriate security, apply your policies across this hybrid multi-cloud infrastructure, and then talk about the next level of problems. How do I move my data between these different instances? How do I automate that movement? And you want to do it smartly, because data has gravity, as Ra had alluded to. And that gravity can come in one or two forms. One is just the capacity, the sheer capacity needed for that data. That has gravity. But it's also the velocity. So it's volume and velocity both, because it might be small amounts of data or comparably small amount of data, but if it's very, very fast, ingestion needed and everything. That creates its own gravity. So you want to be very, very intelligent about building tools and automation into your data workflow that has heuristics in it that says, I'm going to send the workload to where the data is, or in certain cases, it's okay to move the data to where my workload is. And you build that automation into your tooling, into your APIs. One other thing that needs to be considered is, in fact, this is the point that is talked about mostly when people think about workflow, is the compute workflow. So you may have an analytic pipeline that says, I'm going to ingest the data, I'm going to do ETL, then I'm going to do some analytics on it, and then do some kind of AI workload to automate the analytics and to extract the key lessons learned through an AI or machine learning system, and then deploy an inference engine. So in that kind of workflow, you want to make sure that you have a data workflow that matches that it provides access to the data in the format that it needs, at the speed and at the economic point that you have decided you need it for that application, and it automates that entire flow. And I give you some examples of these kinds of workflows where you may decide that, hey, I'm doing some counterparty risk analysis, and the seed data that I need for that is small enough, and the change data that I need to evaluate against is just a market feed coming in. So I can essentially deploy that data anywhere, and that therefore the workload can be easily deployed anywhere. Whereas if you're doing some kind of a data lake that has a lot of gravity, I don't want to move that data around. I want to make sure though that that data lifecycle is managed intelligently. I put it on the right storage tier with the right level of SLA and pricing and protection that I need, so that that workflow can operate appropriately. So we talked about a lot of things, and as must be very evident by now, that this comes at the cost of complexity, right? All of this nice flexibility, nice ability to scale, the agility is very, very nice, but it's creating a lot of complexity. And so there's a need to manage that and automate that and hide that from the end users. And it can be done in several ways. One way is in the public clouds, your IT departments from the enterprise can create a curated service catalog. What that means is for particular lines of businesses or applications, they can decide that these are the infrastructure services and APIs that are approved, that provide the right level of security, the protection, the performance, the cost that is appropriate for that workload. So the application developers or the lines of businesses who are thinking of deploying an application there have a much easier task in terms of choosing the right options from the otherwise daunting service menu that is available from the typical cloud provider. And you can create that kind of a catalog across different public clouds as well as your own private cloud. So that's one way to reduce this complexity, is that the application developer doesn't need to now worry about, hey, do I need to back this up? Do I need to do the right level of archival here or whatever? The service catalog has already taken care of all of that. So they just go pick whatever they need. They build their application, or they do a lift and shift and use the right infrastructure based on this catalog, and that minimizes the friction there. The other thing is, as people are developing microservices, they're increasingly using infrastructure like Kubernetes and OpenShift and container platforms to deploy these microservices. And these microservices have the advantage of being, again, driven through APIs, but there's operators available that can automate the lifecycle, the management of the storage. Or in fact, it can automate all of this for the applications too, but in particular, the storage operators are a nice way to hide some of this complexity. And a storage operator can help you deploy or make the right connection to the right level of storage. Your admins, your storage admins, your Kubernetes admins can create the right kind of storage classes. Again, these storage classes are then curated and made available to the applications or the lines of businesses so they know what to do, which ones to use, and it takes care of the entire life cycle, from deployment to upgrade, underneath the covers doing snapshots and backups, continuous data protection. The IT guys and the storage guys are in charge of doing the initial setup and configuration, but then they get out of the way and the APIs that the application's using hides all of this complexity, but also importantly automates it. So now all of this challenge that I just talked about of picking the right storage classes or performance or backup capabilities are all taken care of, and the lines of businesses can get busy with actually developing their applications that deliver the business value very, very quickly and rapidly. One other aspect that is becoming very important, and this comes from the enterprise data warehouse kind of world, is data virtualization. So I added a link to a Wikipedia entry. It's a very good definition, but it's not complete. I think there's more to this, which is I am not going to try to even move the data around. I'm going to create an abstraction that divorces my application from where the data is, what format it is in, and how it needs to be processed. And I am going to build an application that uses this data virtualization and uses this capability to push the actual processing of the data down to where it resides, and it does all of that, and I can build a composite application that then brings all of this information together and knowledge together and exposes it as a data warehouse or data marts, or I can build business intelligence applications on top of it. So that's sort of the concept that it comes from. But now it's actually breaking through those boundaries, and people are doing this at a much broader and generic scale. So what you can do is the data gravity here dictates, we shouldn't be moving the data if we can avoid it, especially this big data. I can create composable applications, and they are given access to the data as needed. I push the workload to where the data is so that the processing happens closer to that data. I can minimize the copies of the data, the movement of the data, and that actually leads to a much better outcome, because once you have multiple copies of data, trying to keep them in sync is very, very hard. So you wind up with a lot of entropy, and you struggle to create a single source of truth for your data, which is important because otherwise the analytics that you get out of it is sort of suspect. So I'm speaking of it more from that kind of an enterprise data warehouse kind of a background, but I think this concept is becoming very, very important in a hybrid multi-cloud. And whatever kind of applications people are doing, these kinds of methodologies are being exploited now by customers to solve this and tackle this complexity problem. So let's talk about some of the things that we discussed here. So I don't know, Rob, you want to get us started here, and then I'll take over again?
Sure. Why don't you just do the summary, and then we can answer the questions. There's a question up there.
Okay, that's fine. So one thing is, from an infrastructure perspective, this cloud-like consumption of IT provides a lot of benefits. And what is clear that it provides the agility, the flexibility, and the scaling that's needed to meet this explosive storage requirement, this growth requirement. And it's good that we are having this conversations and solving some of these issues, tackling some of these harder problems now, because all indications point to that as the 5G technology proliferates, this is going to become a much bigger problem. So we're getting a preview of this, right? The amount of data that is going to be growing, the sensors are becoming more, they have more fidelity, so the amount of data that's being acquired and the machine-generated data is about to explode on us, like there's a data tsunami coming. But so the good thing is that the public cloud infrastructure, the cloud-like consumption model, right, makes us ready for that. One of the barriers, though, is all this data security, privacy, data protection. And we need to get a handle on it quickly. Otherwise, we won't be able to realize the true benefits of this hybrid multi-cloud. The IT organizations are going to need to extend their existing enterprise data planes to encompass this entire hybrid multi-cloud infrastructure so that they can deal with some of these challenges of security and privacy and et cetera. In order to do that, right, we're going to need good standards, good collaboration, but that's going to be, the vendors and the providers who can do that quickly, right? They're going to gain an edge against the competition. All of this hybrid multi-cloud stuff, right, comes with a lot of complexity, but there are things like service catalogs and data virtualization technologies that are available to help you manage that complexity. And the last thing is that investing in microservices can really help optimize workloads. And they can help you deal with this complexity of the environment, but the real benefit that these hybrid multi-clouds provide, they can help you realize the full potential of that. It doesn't have to be done all at once, though. Rob correctly pointed out, right? Sometimes you just start with the lift and shift model. Sometimes you take partial advantage of it. There are applications actually already developed that are cloud native, born in the cloud, that are already doing things like this. But the truth of the matter is that the mission critical applications that are running the world, 80% of them haven't actually moved yet. And in order to truly realize the potential here, right, we're going to have to address some of these frictions and barriers that we discussed. So I think, thank you. That's all I had. And now I think Rob and I can take some questions.
Thank you, Piyush. Thank you, Rob. Yes, we do have some questions. So for the audience, please submit your questions through the question tab, which you see at the bottom of the page. And we can ask a few of the questions over here directly with the presenters. So Piyush and Rob, the first question I have is, what do you think about keeping the data at the centralized data center and access from multiple locations like cloud providers? So only the compute would exist in the multi-cloud locations. What are your thoughts about it?
So let me take a crack at it, Rob, and then, of course, please jump in. It all has to do with the data gravity. It's definitely a thought, but it depends on the industry and the application we're talking about. For example, let's go to that autonomous driving use case I was mentioning. I seriously doubt that any tier 1 or tier 2 automotive company or OEM that provides services and to those automotive companies is going to be able to create data centers across the world that can take data in from millions and millions of cars and keep it in a centralized location and operate upon it from other locations. I think the data gravity is the volume, the velocity is just too much to be able to do that. And that's not their value proposition, right? Their expertise, their specialization is in another area. So it probably will be that they will delegate that to or work with public cloud providers or managed service providers to handle that part of the problem, whereas their expertise will come in analyzing that data, improving their models, improving the autonomous driving capabilities of their car, or providing additional services to their customers. Because sometimes it's not an autonomous drive use case, it's a connected car use case where you want to update the weather information live or traffic information live back to the car, or if somebody's looking for, hey, they do a search on find me a pizza location near where I am, right? Those kinds of use cases. So they're providing those higher level services. That's what they want to focus on, not how to collect and manage and move all of this big data. So I really think that it's for some applications, the model that is being that was advocated in the question will absolutely be fine. And in fact, there might be regulatory issues in which, even though there's challenges with the volume of data, you may not want to let that get out of your hands, because that's your, there's been quotes in the press saying data is the natural resource of the 21st century. And if that's the case, you want to treat it like that and protect it like that. And so there's some enterprises who will view some part of their data being so critical that they can't let it get out of their data center. So they will use the model that is being advocated for. It really depends on the use case, the type of data, and how they want to process it.
Yep, I think you articulated that really well. I think the only, there may be some instances where you could do that, and it really comes down to, are you going to move the data to the data center to have, work on the data and then move it back? That's really expensive to do, but maybe an instance where you just want to do some machine learning on some data, and all you need is some data set to come back. But so you might move a bunch of data into the cloud, work on it, and then just get some small answer back. That could be maybe an instance where you would do this. But really, as PC said, it really comes down to what the use case is. And in most use cases, you usually need to move a bunch of data into the cloud, and then, and then if you keep on constantly moving data into the cloud, it can be expensive, or it could be, not optimal.
Great, thank you. We have a few more questions. I think I'll summarize the next one in a way. So in a multi-cloud and hybrid cloud environment where you have different technologies, infrastructures and algorithms, and different set of APIs, how do you ensure that your data security is protected and it does not slip through the cracks? What are the key factors in ensuring that you have compatible data security across different platforms?
So that one's did you want to take that, PC, or did you want me to?
No, go ahead, please.
I was just going to start. So that one's difficult because usually most CSPs have a bunch of different levels of security that they have on data, and you can actually pick even more secure methodologies. So a CSP may actually have different levels of encryption on the data. So they'll have encryption for the east-west traffic that's going across the data center. They can have encryption that the CSP puts on across the entire datagram as another level of encryption, and then they can also allow the user who might be using the service to add their own encryption on top of that. So there could be 3 different levels of encryption. And then you also need encryption going to and from the actual client that might be trying to access or push the data. And so you can use, there's also the encryption, like the SSL encryption that happens on that. And then they put in a bunch of different mechanisms to keep keys secure throughout the data center. They have different levels of keys that themselves are encrypted.
Yeah, so I think Rob did a great job answering that. Let me just chime in by adding a few more things to keep in mind. One is, you as an enterprise have to do the analysis of your own security posture. So, and there's different ways to achieve the end goals. You may decide that the underlying encryption or protection being offered by the cloud provider or the managed service provider is sufficient for your business needs, and you just and you leave it at that. And it could be that even in a hybrid multi-cloud scenario, various cloud providers have enough of a protection that it meets your needs. So one way to check this would be, hey, are they certifying to a specific level of FIPS or NIST or something like that? And you say, yep, that meets my needs. I'm okay with that. The other is you say, yeah, I'm not too convinced, and I need a level of protection on top of that. And so you could deploy your own encryption or security product that supports these hybrid multi-clouds and does protection at your level of the data, and it doesn't matter where the data is, it's encrypted or protected using your choice. Now, you're going to have to make some kind of a determination, right? Because as Rob mentioned, you could wind up with like 2, 3, 4 levels of protection here. Every time you do that, that comes at the cost of some kind of efficiency or performance. So you're going to have to decide on that trade-off. And certain classes of applications might be okay with one level of protection versus some need that extra protection. This similar security concepts will have to be applied for authorization, right? You create like an or authentication as well. So you wind up with a sort of a hybrid scenario in your enterprise based on the applications and the SLA that you need. You will do a blend of these.
Thank you, Piyush. I think we are running towards the top of our hour, so thanks a lot. I just want to highlight over here that there are a few senior resources, like some of the webcasts, which I am highlighting over here. And for the audience, we have an upcoming webcast on June 23rd, which is on the multi-tenant, multi-cluster Kubernetes data apocalypse is coming in future. So please do register for that, for the future webinars. And thanks to Rob and Piyush for a wonderful session. And thanks to the audience. I just want to convey here again, you may download the slides from the bottom of the tab here, and we will also post the Q&A blog in next few weeks. So keep tracking the link. And I encourage you to follow us on Twitter for announcements on our blog postings as well as other SNIA CSTI webcasts. So thank you, everyone, and have a great day. Take care.
Thank
Bye.
you.
Thank you very much.